Hello and welcome to Unit 4, Part 2. My name is Mr. Bell, and today we're going to talk about the standard form of a quadratic, and we're also going to solve some literal equations for specific variables. On these first two examples, it says to place the following quadratic equations in standard form. So let's talk about standard form for just a second. I'm going to write it up at the top in green. Standard form of a quadratic looks like this. It is ax squared plus bx plus c is equal to 0. And basically what that means is you put the x squared term first, you put the just x term next, the constant if there is one last, and it has to be set equal to 0 to be considered in standard form. That being said, let's take a look at number 1. It says negative 2x plus 4 equals 3x squared. And I'm going to add some tips and some suggestions as I go. One suggestion is, if it's possible, leave the leading term, the x squared term, positive if possible. So in this case on number 1, I want to move the negative 2x and the plus 4 to the right side of the equation so that I can put it in standard form. So if I'm going to move this minus 2x, I'm going to begin by adding 2x to both sides, leaving me with 4 equals 3x squared plus 2x. Remember, those two are not like terms, so I can't combine them. I just have to write them beside each other. And the last step here, to get rid of this 4, we would subtract 4 from both sides, leaving me with 0 on one side, 3x squared plus 2x minus 4 on the right side. Now that quadratic is in standard form in the ax squared plus bx plus c equal to 0 form. All right, let's try the same thing on number 2. In this case, I've got 5x squared plus 2 on the left is equal to 7x on the right. This one's a little easier. All I'm going to do is I'm going to subtract the 7x from both sides to move it to the left, leaving me with a 0 on the right and a 5x squared minus 7x plus 2 on the left. Notice how I rearranged the left side so that the x squared term was first, the x only term is second, and the constant was third. Now my quadratic is in standard form. On this example number 3, it says to solve the following literal equations for the specific variable. So we've got d is equal to r times t. Solve for the r. So we're going to use the same rules of equations that we've learned in the past, except this time we're going to apply them to various letters to isolate the one we want. So if I start with d equals r times t, and the question says to solve it for the r. So if I want the r by itself, I need to undo this multiplication of t that's happening to it. Opposite of multiplying by t is to divide by t. If you do it to one side, you got to do it to the other. This leaves me with r by itself on the right side and d divided by t on the left side. Even though I don't actually have numbers in this problem, this is as far as I can simplify and solve this equation, leaving us with r is equal to d divided by t. Example number 4 says that a is equal to 1/2 b times h, and then comma, solve for the b. So in this case, I want to isolate this equation for b. I want the b by itself on one side and everything else moved to the other. So let's start by writing this down. A is equal to 1/2 b times h. And remember, one of the ways to get rid of the fraction, the 1/2 in the front, is by multiplying by the reciprocal. That will cancel the 1/2. You multiply the left side by 2 over 1. You got to multiply the right side by 2 over 1, leaving me with 2a is equal to b times h. And since I wanted to solve this equation for b, these are being multiplied right now. There's no sign in between them. So to get b by itself, we'll divide both sides by h, leaving me with b is equal to 2 times a divided by h. And example 5 says a is equal to pi times r squared. Solve it for r. This one's a little tricky, so you might want to watch. Let's start by rewriting our equation. If I want to isolate the r, I'm going to get rid of this times pi as my first step. Just as if it was a coefficient, I would do the same thing. This leaves me with r squared is equal to a divided by pi. Now think to yourself, how do I undo squaring something? Well, the opposite of an exponent is taking the root. So the opposite of r squared, to get just r the way I want my answer, I would need to square root the left side. Square root just means what number times itself gives you that value. Well, r times itself would give me the r squared. So the square root of r squared is r. If you square root the left side, you got to square root the right side. And this is how you'll leave your answer. R is equal to the square root of a divided by pi. All right, thanks for watching and hope this helps.